Hi, today I'm going to be talking about how to increase your health span and how to remain youthful. What brought this on was I read an article this morning about early frailty. An Australian study found that nearly half the people in their 40s showed as many symptoms of early frailty as people in their 70s. So I want to take a minute and talk about that. I guess it's not too surprising. One of the trends over the past few decades has been that people are living in older bodies at a younger age, and that's not how it's been historically. Just a couple of examples. In Sparta, active duty in the army was from age 20 to age 60. 19, you weren't old enough, you weren't fit enough, and age 60 were still considered in good enough shape to be in the army. Also, recently there was a study done of the New York City Marathon times, and what they found is as your age progressed, starting at age 17 up through 28, your times improved, and then once you hit 28, the times on average started to get worse. But it wasn't until between the age of 65 and 70 that the times fell down to where the 17-year-olds had been, and 17 that's a senior in high school. That's somebody who's pretty darn athletic, and they were able to retain that type of athleticism until the age of 65 or 70. So if we go online and look for pictures of fit women in their 70s, there's a lot of them. I didn't do a search for unfit women in their 70s because that just didn't seem right, but here's fit men in their 70s. I mean, look at some of these guys. That's okay, he's in his 60s, my bad. Here's a man in his 70s. There's Arnold carrying some weight. One thing you'll notice about these people is they all have a fair amount of muscle mass, and that's not just coincidental. Let me walk you through some of what science has to say on this. So skeletal muscle, we've learned, is an endocrine organ. It's actually your body's largest endocrine organ. And what that means is muscle its job isn't just to move and contract. It's also producing chemicals that we'll talk about in a minute. Unfortunately, so is fat. Fat is also an endocrine organ, and it's also secreting chemicals that you need to be aware of. Adipose tissue chemically inhibits testosterone and vice versa. That's what it says right here. In conclusion, adipose tissue and androgen influence each other in a bidirectional and reciprocal way. It takes your testosterone and converts it to estrogen, or it takes your male chemicals and converts them over to female chemicals. So yeah, you get man boobs. Adipose tissue causes what is called hypogonadism. Hypo means reduction, gonads, well, are your gonads. So it leads to hypogonadism. You may have heard it said that sitting is the new smoking. In other words, sitting is as bad for you as smoking. Well, here's an article that talks about why. It's actually not an article, it's a research paper, but it starts with physical inactivity, which leads to abdominal adiposity. In other words, you start building up belly fat, abdominal adipose tissue. And the bottom line, when you get down to it, you have system inflammation, and you end up with dementia, depression, type 2 diabetes, cardiovascular diseases, breast cancer, colon cancer, and so on. As we get old, there's a concept called sarcopenia, and sarcopenia it basically just means deterioration of muscle tissue with age, and sarcopenia is closely tied to a lot of elderly diseases. And when we hear about younger people who are also starting to let their muscles deteriorate and go away, I mean that's part of what's causing this whole frailty issue that we're encountering and that the article was talking about. Good news is that you can reverse sarcopenia. People as old as in their 80s and 90s have shown dramatic improvement in all kinds of measurable ways by starting weight training. It basically helps to get your chemistry going again. Okay, so let's talk about what these chemicals are. So there's a type of chemical in your body called a cytokine, and these are these are things that your body secretes. They're signals that have effects on other cells. One of them that we want to talk about is myokine, or a myokine. So a myokine, it's a cytokine. In other words, it's a chemical signal that is released by contracting muscle tissue. So myokine kind of ends up being the hero in the story. Myokine appears to be the signal that is causing all of these things to happen. Myostatin, which is related to myokine, is kind of from what I've been able to find, it seems to be somewhat the inverse of a myokine. It's linked to muscle mass and bone density. So what they did is they took rats and they suppressed myostatin, and when they did, these mice bulked up and had more bone density. And of course, that's going to get some bodybuilder trying to figure out how to suppress their myostatin so that they can bulk up more. But anyway, myostatin is the chemical. It's the chemical link between muscle and bone density. You probably heard that you should lift heavy weights or do a lot of load-bearing exercise in order to not have deteriorating muscle density. Well, myostatin appears to be the chemical link between the two. There's articles on the influence that skeletal muscle has on systemic aging. So by exercising your skeletal muscles, and that's just a fancy way for saying muscles, to differentiate between your heart muscle, other types like that. Okay, so if we're interested in maximizing longevity and health span, and let me just take a minute and say, you don't want to live to be 90 if you're going to be sick for the last 20 years, but I wouldn't mind living to be 90 if I was healthy until age 89, and that's how it used to be with humans. That's the way it is with wild animals. Wild animals, you don't see an elderly deer wandering around, partly because they're killed off, but even with horses and other animals generally stay in top or near top athletic condition or physical condition until about their last year, and then they fade away and die. That used to be the way it was with humans, but now humans tend to deteriorate for the last couple decades, or in a lot of cases, how many people do you know who hit their physical peak when they were in their 20s and have been deteriorating ever since? It's really pretty sad. So, do you know what? Even if you don't live longer, if you can stay like a 20-year-old until you're 70, is that not worth it? Or like a 17-year-old until you're 65 or 70, in the case of marathon runners, or 20 to 60 is the case of the people in Sparta. Wouldn't that be worth it? Anyway, so this article talks about how all of these approaches converge on autophagy. And autophagy I've talked about in other videos, especially videos related to fasting. Autophagy literally means self-eating. It's a Greek word, autophagy. Phagy means to eat, etc. Anyway, so autophagy is the process by which your body goes through and cleans out cells that aren't doing what they need to be doing. And based on some late research, this was just published in 2019, there's a lot of evidence that autophagy seems to counteract the effects of aging. I do a 4-day fast once a month. Autophagy is a big part of why I do that, and it's a big part of what happens during that process. But it looks like it's also related to exercise. And I have an article here from 2012 talking about how exercise induces autophagy. In other words, exercise makes autophagy happen in peripheral tissues and in the brain. So let's pause for a minute to just ponder this sentence. There's strong evidence to suggest that exercise promotes both health span and lifespan in worms. One more time. Exercise promotes health span and lifespan in worms. How did they get the worms to exercise? That's what I want to know. Imagine you've gone through all your years of medical school and you've decided you're going to be a research doctor. First assignment, you need to figure out how to make worms exercise. Anyway, all right, moving on. So there were, a few years ago, I read what appeared to be several contradictory articles. I read an article one week that said people who have low body fat tend to live longer. Then I read an article a couple weeks later that said people that have higher body fat tend to live longer. And then I read another article that said people have normal body fat tend to live longer, and I mean, who knows? But I found an article that seems to reconcile some of that seeming contradiction. And here we go. So several studies have shown a J-shaped association between body mass index and mortality, suggesting that both a high and low BMI are associated with premature death. However, it appears that the risk observed at low BMI is more closely linked with low fat-free mass, in other words, with low muscle, than with low fat mass. So the article that was talking about people who have low BMI, body mass index has nothing to do with the ratio of fat to muscle. It's height versus weight. So people with low BMI tended to have low muscle. They weren't producing myokines. You know, so that's also one other thing. Talking about autophagy, insulin decreases autophagy and leads to cartilage degradation. So that's one of the reasons I've been doing the keto diet, for example, or I mean, keto is one example, but just keeping your insulin levels under control. Insulin decreases autophagy. So decreasing your insulin, you're able to avoid that. And so there's a lot of diets now that focus on decreasing insulin. Anyway, I need to wrap up. There's been a lot. There's a lot to think about. Going back to frailty, you know, I'm almost 50, and I don't want to be frail. I don't want to be, you know, weak and sickly for the next 20 or 30 years. Have you know, man boobs, hypogonadism, and not be able to run, not be able to. I mean, who wants that? Going back to the article on frailty, like nearly half of 40-year-olds are showing frailty symptoms. I don't want that, and it seems like the key to that is increasing strength through high-intensity exercise. Thank you for sticking with me through this, and click like, click subscribe, share with a friend, and we will see you next time.